All right, class, let's get going. So, questions, class. Hey, questions. Thank you. I'm not mad. I down the rack. Any questions at all? I figured I got some. I actually got quite a few. Nothing else? Gabriel, are you here? Oh, there you go. You got any other questions or not? None? Yeah, sure. All right. Can somebody just tell me what it is? By the way, how'd your test go?
There were impossible problems on it.
What test was it?
Power.
Was it that bad?
He just didn't give us things that we needed.
It's a classic Dr. You had the wrong
I didn't mean to disrupt your.
It's been a long day.
Whenever I hear that much chatter, usually something is really whack.
They're probably talking about education.
Oh, and we got our Diggy grades back.
Yeah. What?
We got our Digitron grades back from our exam.
Oh. So it goes from bad to worse.
And after this class, it's gonna get worse.
So on the bright side, the break is upon us. All right, guys, can you give me this problem, please?
Yeah.
All right, just somebody read it. Anyone?
E equals 120.
E equals
120.
120. I think I did this for. Didn't I send this to everybody? Okay, go ahead. We'll do it again. Cosine of what?
6 pi times 10 to the 16th
All right, go ahead.
minus 0.08 pi y
A.
z.
All right. What do they want?
Well,
They give you H?
yeah, we're given h.
Okay, what is H?
2 cosine. 6 pi 10 to the 16th.
Go ahead.
And minus 0.08 pi y.
A.
X.
Okay. What do they want?
Mu relative and mu naught. Or, sorry, mu relative.
All right, we want mu relative, mu naught, sorry, epsilon relative, right? What else?
That's it.
We're going to do the whole thing. I put a lot of this up there. We're going to do wavelength, phase velocity. We're going to go through and talk about eta. Y'all remember the intrinsic impedance? We're going to do all aspects of this thing that I might ask. Hint that I might ask. I hope I have your attention. All right? Everybody ready? Now, how many tried this one? Just give me a hand. All right, we're going to go through it. If you don't see anything, just say something. I'll stop. First thing I'm going to do is identify the most important features of this thing. Does everybody see that this is omega and this coefficient of y is beta? Everybody follow me. Show of hands here. All right. Important you notice that. Next, I want to know the direction of propagation. I'm going to use a unit vector, and this is a unit vector in the direction of propagation. Can everybody hear me? What direction is it and why? Anyone? Direction of propagation. Why is it that? You're right. Because it's minus beta, and the coefficient here would be the direction of propagation. Here it is y. It could be z, it could be x, or any combination. I'll talk more about that later. Now, if this was a plus, what would that mean, class? In the minus ay. Does everybody hear me? All right, so this is in the positive ay direction. All right, next, I want to know, let me do it this way. Next thing I want to know, we'll get all the stuff in a second. I'm going to just show you this. We'll do it next. Remember, what is eta defined as? The intrinsic impedance of a medium. Now, it's defined two ways. One in terms of the field quantities, the other in terms of the intrinsic parameters. Everybody follow me? So in terms of the field quantities, it's really magnitude of E over magnitude of H for a forward propagating wave. Do you all agree with that? Do we have those quantities, class?
Yes.
I didn't say this explicitly. The coefficient of this cosine is E naught. The coefficient of this cosine, because this is the E field, this is going to be H naught. Does everybody follow me? You can show me as if you do. I'm being very clear about this for a reason. There are sometimes people that have a little uncertainty, especially if you've had a test today and you were studying for that, not this. So is everybody clear on that? The ratio of the two. Think of it, the impedance here has the units of ohms. E has volts per meter, H has amps per meter. Volts per meter over amps per meter is ohms. That is the unit. Y'all follow me? So here, we've got this. The magnitude of, I really should call E naught H. This is equal to 120 pi over, and that is 2, right? So that is 60 pi ohms is that ratio. Now that's also equal to something with the intrinsic parameters of the medium. And that 60 pi ohms is also equal to what? And I'm going to put the full thing up here. Square root of j omega mu over sigma plus j omega epsilon. Does everybody agree with that? How many see this? You got, I didn't see hands up. You all follow me on this? That is a ratio. Everybody here, guys? Yes?
Oh, no, no.
Oh, you see it? Everybody. Does anybody not understand this? We did this last time, and I tried to really underscore. Now that is the general form, right? Now if you take a look at this right here, what is the value of alpha, class, just by inspection? Take a moment. What does alpha mean, actually? Well, when we have the propagation constant, that's alpha plus j beta, and that's equal to, in terms of the intrinsic parameters, what? J omega mu times sigma plus j omega epsilon. Does everybody follow me on this? Now, if sigma is 0, then this is just j omega times j omega, which is j omega squared square root, so this becomes j omega times square root of mu epsilon. Do you all follow me on that? How many see this right? Take a moment. I mean, you follow me. I'm trying to be real clear about this. Now, what is the value of alpha? Just look at this. That j is the coefficient of imaginary term that defines beta, isn't it, class? We know. Matter of fact, we could put that down. We could say that beta, right here, which we defined as 0.08 pi, right? That's actually equal to omega, right, times square root of mu epsilon. I'll get back to this, but everybody follow me on this. By inspection, we find the value of beta, but beta is also equal to this if sigma is 0. How did I know that alpha, or how do I know that these two waveforms have a sigma 0, or alpha? Why? Is there any exponential decay, class? None. That means it's e to the 0. That means alpha 0. Do you all follow me? If alpha is 0, what else is implied? Sigma is 0. I'm trying to really make sure you got a handle on that. If you don't see exponential decay here, e to the minus alpha y, because it's propagating in the y direction, it's lossless. So you can even claim that. And if it's lossless, then beta is equal to this. Does everybody follow? Now, if you look close here, since sigma is 0, I wrote this down in its entirety. Please pay attention. This is the general form. If sigma is 0, I can erase it. And you'll notice the j omegas cancel as well. So this cancels. And now you can see that really I have the square root of mu naught over epsilon naught times the square root of mu relative over epsilon relative. Everybody follow me on this, class? How many see this? You good with that? Andrew, can you see it in the far back? Can you guys see it? Far back. You got it? All right. Now, it's 60 pi, right? Let me write it here. So we have 60 pi here. What is the square root of mu naught over epsilon naught? Always. 120 pi. Y'all hear me on that? Or 377 approximately. That never changes. So that means the square root of mu naught epsilon naught we can render as 120 pi. A lot of times they call it A to 0. It means the actual intrinsic impedance of a vacuum where the atmosphere we're in here. So that's 120 pi ohms, or about 377 ohms. All right? Now, that's 120 pi ohms, but it's still times square root of mu relative over epsilon relative. Is it not, class? Y'all with me, everyone? I hope I'm being as clear as I can be. All right. So, based on this, we have a relationship between mu relative and epsilon relative here, and we have a relationship between mu relative and epsilon. I didn't do this, but I'm going to in a second. If I look at this, I have right here beta is equal to omega, and I'm going to complete this. Now you see there's a mu and an epsilon there, right? I'm going to factor out the mu naught epsilon naught, and also factor out the mu relative epsilon relative. I'm doing this for a reason. Y'all with me, class? All right. Tell me something about this. What is the square root of mu naught over epsilon naught? Or better yet, what is 1 over the square root of mu naught epsilon naught? Anyone? Say again? It is the speed of light. Isn't it, class? How many know that? As a matter of fact, this is something you got to commit to memory. So when you talk about c, which is approximately 3 times 10 to the 8th meters per second, that is the velocity of light in a vacuum, that's equal to 1 over the square root of mu naught epsilon naught. I'll make one comment about this. When we approximate epsilon naught and mu naught, we get a velocity of light about 3 times 10 to the 8th meters per second. But the real velocity of light is 2.999 with a lot of other numbers after. Y'all follow me? So this is a very close approximation, but not exact. So don't get hung up on that. Y'all care? Everybody with me on that? It's good for anything you have to concern yourself about doing. That means I can replace this as 1 over c. Do you all see this, class? If you're taking notes, I'll slow down. Y'all with me? So this is 1 over c. Right? And now you still have mu relative epsilon relative with square root, right? Now you have, and I can put the values in, I have 0.08 pi, and then I can divide that, this is beta, I can divide that, well, I'll just set it equal to this. That's equal to omega, where's omega, 6 pi times 10 to the 6, right? It's going to be omega, and then it's divided by c, which is 3 times 10 to the 8th. And then it's times the square root of mu relative epsilon relative. There's, call it equation 1. This is equation number 2. Do you all see that? We have 2 equations, 2 unknowns. It's solvable uniquely. Just everybody follow me on this. How many did that? Tried that? A lot of you didn't? How would you solve it? Just tell me. Anyway, it's the obvious way. We don't need a matrix. What do we do? You all agree this is true right here? All right. Now, you can do whatever you want. I don't care. But when I see this kind of stuff, I simplify. I got 60 pi, I got 125. This becomes a half. Everybody follow me on this? Now I got a half equals square root of something, so I square it. Y'all with me? Now I get this. It's up to you how you do it from here on. What else? It means epsilon relative is 4 mu relative, right? Y'all follow me? Just multiply both sides by epsilon relative. You get epsilon relative is 4 mu relative. Right? Agree? This is not tricky here. And what do you do over here? Oh, it's messy, but what can you do over here? I'll put the whole thing down. So if I want, say I want mu relative, so I can say that this is 0.08 pi, right? Then 3 times 10 to the 8th. And then I can divide that by 6 pi times 10 to the 6th. And then that's equal to this, but I'll just square it. Now, I don't know what that is, but you all follow my thought process, right? And what is that equal to? That's mu relative epsilon relative, right? What's epsilon relative? 4 mu relative. So it's 4 mu relative squared. Does everybody follow me? If I divide this by 4 and take the square root, I get mu relative. And what is mu relative? I know I put the answers. What is it?
2.
One of them's 2, right?
Yes.
All right, so this is 2. What's the other one? And you get that by doing what? 4 times that is 8, right? So epsilon relative is 8. Who asked this, by the way? I'm just curious. Was Gabriel? Did you ask? I don't even see you. Did you ask this? Does everybody follow me on this one? Now that was a general form of the problem. We're not done yet. Not everybody with me. How do you get the phase velocity? I'm gonna slow down here. This is not the speed of light per se. It's the speed of light in that media, which is going to be reduced. Do y'all agree with that? How do you get it, guys? What is one form? It is omega over beta, right? That's one form of it. So we can say it's omega over beta. I don't know what this is. So this is 6. If you haven't done this, let's do it together. 6 pi times 10 to the 6. That's radians per meter divided by 0.08 pi. And it looks like the pi's cancel, right? What do you get for that? I don't know. 0.75 times 10 to the 8th? Is that right? Is it 3/4? I don't know. Is it 0.75? Anybody do it? Anybody confirm that? I got one head shaking. Anybody else? Just do it. It's not tough. Hint, you may see this again. Big hint here, huh?
7.5
Times 10 to the 7th, isn't it? 7, yeah. That was 7.5 times 10 to the 7th meters per second. That's the velocity of this wave in the media it's propagating. Y'all follow me? All right, pay attention. How do you get wavelength? I'm going to erase some of this stuff. So we got velocity. You need it all. What's the general equation for wavelength of a propagating wave? Anybody remember? Say again?
2 pi over beta.
That's right. It's 2 pi divided by beta. So if we take 2 pi divided by beta here, what do you get? Let's see. I don't know. 2 pi divided by 0.08 pi. What's that? Pi's cancel. Say again?
25 is
Let's see. Pi goes, right? Then I got 2, that's 4. What is 1 over 0.04? 25. Isn't it? You agree with that, everyone? 25 meters. 25 meters. All right? Next, and you should all nail this one to the wall. What is the frequency in hertz? Ooh, that's
3 megahertz.
No, I mean, how did you get it?
Oh, well, you got omega 6 pi times 10.
Y'all follow me? He's saying omega over 2 pi. It's, in other words, 2 pi f is omega, right? So you take omega by 2 pi. Is everybody following me? I'm just going through this whole, I mean, I'm not going to put the numbers, but y'all follow me on this one. All right, what else could we get? Let me say again? I put one thing up there. Did you have a question? If you do, just, I mean, I don't care if you collaborate. What I'm trying to do is make sure how I can help. Did you have a question or not? I don't care if you're standing up. I just need to know if I can help you.
I got lost after we got the 1-4.
Oh, that's right. I erased everything. Right. Now here's the only thing I'm doing. I'm getting eta, all right, from the electric field values, E over H. That's the value. But that is equal to the square root of mu over epsilon. You understand that? How many do? That's the first equation. There are two unknowns, mu relative and epsilon relative in that one. Then I got the second one, beta is equal to omega times square root of mu epsilon. That's beta over c, the velocity of light, times the square root of mu relative epsilon relative. We identified beta as 0.08 pi, right? So now we have two equations, two unknowns. Solve it however you want. It's got unique solutions. Do you all follow me? You can, if you don't understand where I got the 4, I did some squaring and I would basically just reduce those two equations to a single equation with one unknown, and that was the only thing. You can do it many, many ways. You can solve for epsilon relative or mu relative, it doesn't matter. Do you all follow me? The other, as soon as you have one, you got the other. Does that answer your question?
Yes.
Everybody? All right, not done yet. All right, we pretty much got the idea behind this. Now we're going to take it to the phasor form. Everybody pay attention. The phasor form that you will be asked about on the quiz. Everybody got some attention? All right. So, we got the parameters. Now we're going to take this E field and we're going to take it into the phasor form. All right, this is going to be a vector phasor. So how do you get that? Now, I'm going to show you the general form will be a magnitude called E naught. Then, for phasor form, there is no e to the j omega t. There is no omega t. Do you all follow me? That is suppressed because it's at a constant frequency. So you have E naught, then you're going to have E, and if it's a wave traveling in the positive direction, positive y in this case, it's going to be minus j beta y. It is lossless. Do you all follow me? And after that, you have to put the vector's polarization. Its polarization is in what axis, class? AZ. Now I have that. What would H be? Now look, phasor form of H is what? There would be some H naught. We'll put the values in a second. Y'all follow me? That is the magnitude. If you want to know what I'm talking about, this is E naught right here, and this is H naught. So it's H naught, and it will have the identical kind of form here. E for a lossless wave, e to the minus j beta y. But what direction is it in? I mean, here I gave it to you. What direction is this? Right? Y'all in it, but I'm going to show you a trick that I think you're technical. Yes, sir.
What's the difference between one of the problems? It was E minus j beta c and y.
C would be the direction of propagation. Do y'all follow me in that class? The coefficient of the beta is the direction of propagation. If it's minus beta times something, minus j beta, or if it's minus beta times a coordinate, it's going in the positive direction related to that coordinate. If it's plus, it's going in the negative. Does everybody follow me? Now, hear me on this one. I have people in my office, I try to do this in a way that's understandable. If you ever are wondering about the orientation of either the propagation vector, the E field or H field, remember this. If you take a unit vector in the direction of the E field, all right, that's a unit vector, and you cross it into a unit vector in the direction of the H field, y'all with me on this? Unit vector is a magnitude of 1 and it's oriented not in the direction it's propagating, but in the direction of polarization. Y'all with me, everyone? It is equal to necessarily a unit vector in the direction of propagation. Now what that, y'all with me, class? I don't know if you got this in physics or not, I really don't. So if you have an E field in this direction, this is a propagating wave, and we're assuming E and H are linked. In other words, one is inseparable from the other. All right, if one exists, the other. A propagating wave, and I have an H field in this direction. So E up, H this way at a point in space-time. If you take the E field vector direction and you cross it into the H field, your thumb points in the direction of propagation. Do you all hear me on that? With me? I'll see this on the quiz, all right? You just take your index finger on your right hand, point it in the E field direction. Then take that and rotate it into the direction of the H field. Your thumb on your right hand points in the direction the wave is propagating. Y'all with me? E cross H is that. Y'all with me, class?
That's what our professor did. They did like this and sort of walking straight.
Well, what I see from my point, my vantage point is this, and I'm not kidding. On finals, I have to watch this. I'll see. And I mean, people, they're really desperate. It's something, but this is very helpful. If you have any, yes, sir. Can I get a volunteer from the audience? You were really doing it well. Go ahead, Emily. Just show them how to do it. Or better yet, you were really doing it.
So the way that
Yes, stand up. Might as well have some fun.
you kind of like, okay. So you go like E field, like the H field, and then you walk.
Right hand rule. Take your right hand. I hope you got one. Put it up. Just put it up. Right. Now, index finger right hand, direction of E field. Rotate it into the direction H field. Your thumb points in the direction of propagation. It doesn't matter which way it is. What if it's this way? If E feels that way and the H feels that way, it's going down. If E feels that way and the H feels that way, it's going up. Y'all hear me? I'm trying to make it simple. It's as easy as that. And this is for propagating. That was good. All right. Y'all with me on this? Let me finish my thought before this it's already out of hand, I guess. All right, now, this is the last point I have for today before your quiz. This may help someone. You don't have to do a curl all the time if you have propagation. Thank God for the milk. All right, here's a trick. You know, I mean, basically that'll do it. I don't even leave that up. Bring a quiz. I can't believe it. All right, I'm going to show you one other thing that you'll like. How many are staying for the game? All right, we got a good, there's going to be quite a few people here. Now, did you know that this team, New Mexico State, has won the last 6 in a row? They're actually better than you think. This is not just a tune-up game. Usually before the Iron Bowl, they put a team that will allow us to try all sorts of stuff without being in danger of losing. This is a real team here. This is a tough team. So I'm hoping for the best. But I don't bet on things like that. I've learned my lesson. All right? Now, pay attention. If you have propagating waveforms, y'all with me? Then these two equations will save you. If it's a propagating waveform, you have to be in the phasor domain. If you want the H field from the E field, it's simply equal to 1 over the intrinsic impedance of the media times the unit vector in the direction of propagation, right there, crossed in the E field. You all see this, class? I'll give you the page number. I'm going to do the H field too. This is really nice to know. So, just give me a second, I'll get it for you. Pardon me?
Page 327.
327? Thank you. All right, it's on page 327, equation 6.33, if you have it. Then they have, if you have the H field, you want the E field, you put a minus sign here. It's equal to minus, and then it's eta, and then it's a unit vector in the direction of propagation crossed into H. Now, is that the form they have, by the way? All right. Y'all hear me? These are phasor quantities. What?
Okay, yeah, these are the phasors, not the fields, right?
Well, you could do it with the field quantities, but there's a couple of, just do it with phasors, all right? That's, I don't want to even start that because I'll get into a long discussion about when there's a lossy wave, things mess up. This will work for lossy or for non-lossy waves. It always works, but it has to be propagated. It has to be a plane wave propagates, not near field. In other words, fields very close to the source. This always works. Now, you know how to get eta, right? I'll put it down. What is eta? Generally, it's the square root of j omega mu over sigma plus j omega epsilon, right? If you have that, and you have either E or H in the phasor domain, you can get the other. You know how to find the direction of propagation, correct, class? Now that is a nice thing to know. And I'll even leave that up there. I better put the other one because I said I would.
Yes.
All right, now hear me on this one. With that in mind, if you have propagating waves at a constant frequency, you hear me? So you can take it to, you don't have to do curls. You know one, you can get the other. That is something you were concerned about. Y'all with me? I think you just said, you gave me the impression no curls are good. Y'all with me, class? All right, I'll even leave those two up. And that, this is like Christmas. So spread out, and I'm going to move people, spread out as far as you can from other people. Have at least one seat, preferably two, between you and your friend. And as best as possible, try to sit every other row.